All right, I'm back. I'm on page 245 this time, and I'm at the very top. And we're going to do something that I think is really cool. So we're going to approximate the volume of the solid form by rotating the semicircle with equation f of x equals square root of 16 minus x squared. What? The solid form by rotating the semicircle, the region bounded by, let's say, the semicircle with equation f of x equals radical 16 minus x squared and the x-axis. That's another thing that if I were into editing notes, I'd probably go ahead and edit that right now. So to do this, step one is probably like, what does this look like, right? So it's a semicircle, it has a radius of 4. If you're like confused about it, what you can do, potentially, you shouldn't be confused though, but if you're confused, you could do this, square both sides, and then add x squared. Get that. Now it's obviously a circle of radius 4 centered at the origin, but you should know your semicircles. They come up like way more than you would think. So I'm going to sketch it there. So it's negative 4 to 4. Okay, so I'm going to need a delta x. So delta x is going to be 4 minus negative 4, so 8, the diameter, in fact, over n, so 8 over n. X sub I is going to be where I start, which is negative 4, plus I delta x, so I'm just going to write 8i over n. And then I want to write a summation, so I'll make it a function of n. V of n is equal to, from 1 to n, so we're always doing the right endpoints. I can't stress that enough. It's where you start, add delta x, find a radius, rotate it, add another delta x, find the radius, rotate it, and keep going. So this is going to be pi, because we're doing pi r squared h. R is going to be f of x sub I squared, so pi, the radius squared, and then the height, which is delta x. Okay, so I usually write them like that. They all look exactly the same because of that, but that's okay. It's like trig graphing. All right, so calculator, let's switch it up and get some values here. I'm going to fill them in as I go. Save a small measure of time. So this is still the last problem. I'm going to start a new problem, I guess. Doc 4, enter. And all right, f of calculator, please. Okay, f of x set equal to square root 16 minus x squared. Okay, and then so volume as a function of n is going to be pi. Now, what I've been doing is I pulled delta x out because I want to make sure that it's being multiplied by like the correct things. In this case, you could just leave it in, it wouldn't make a difference. That's really like a 2-curve situation. If you have 2 radii that are going to go, you need to be very, very careful about that on the calculator. And then f of x sub I, in this case, is negative 4 plus 8i over n. And then we're going to square the radius. So it's pi is right here. The radius is this, pi r squared, and then the height is this. So this is good to go. All right, let's do this. V of 2 with a decimal, so I get a decimal back. I'm just going to paste it down. V of 10 with a decimal. V of 100. So it feels like we're closing in on something. You have 1,000. Now it really feels like we're closing in on something. And V of 5,000. So sometimes they take a little while. Not in this case, really. So I'm going to jot these down while you also jot them down in the table. So I got 201.062. 3 decimals all the time. I don't want to hear complaints. 402. 268.056. So now you start feeling like this 268 seems like a thing. 268.082. And then, whoa, okay. Now you're not even looking at the iPad. I did a weird thing. I'm not even going to tell you what. 268.083. 268.8-ish seems like a really good, 0.08, I should say, seems like a really good guess as to the exact value of this. So the next thing that I want to do is find the exact value according to the note. So I'm going to do that while I'm here. So the exact value should be the limit of this thing. Limit as n approaches infinity. You should use the pi key, just like hit it a couple times, you get infinity. V of n, we already have stored. Enter, 256 pi over 3. All right, I'm going to go back to the notes, and I will write that in. Go, screen mirror, blah, blah, blah. Okay, you can see I filled in the table. Woo, can you get? Okay, you can see I filled in the table. And if you didn't do that already, take a second and fill that in. All right, write the limit using proper mathematical notation and use your cast. What limit? Write the limit that will give you the exact volume. These could use some touching up. I might actually do that. But as I've mentioned in previous videos, I am now very, very motivated to never change the page numbers on this because I've put in a lot of time on these. So like any edits are gonna have to be somehow not changing page numbers. I don't know how that's possible. What was this number? Let me see. This is where somebody in class would just like yell it out, but nobody's in class right now. 256 pi over 3. Okay, so why is that interesting? I mean, hopefully that's kind of interesting to you. I mean, what do you get when you rotate a semicircle? You get a sphere. So I think what I just found is the volume of a sphere with a radius of 4. What is the volume of a sphere? So the volume should be 4/3 pi r cubed. That came up early in the notes at some point. I don't really remember when, but I remember talking about that. So and then we talked about the surface area. The surface area is 4 pi r squared, and now we've had the exact same conversation again. So our radius is 4, so the volume should be 4/3 pi 4 cubed. So 4 cubed is 64 times 4 is 256. 256 pi over 3. How amazing is that? Like, this is one of those things where it's not how they came up with the formula originally, but it's very interesting that we can now do this. We can come up with a formula all on our own. And I think what I'll do is come back in the next video and do that. So I'm going to be back instantaneously as far as you're concerned. And we will find the volume of a sphere in general using this process and our calculator. And then we're going to do a cone. So I will see you then.